This is why cats almost always land on their feet. The question challenged physicists for over a century before a mathematical solution finally arrived. The final answer pulls together three biological adaptations: an aerial trick borrowed from figure skating, and a survival paradox where greater heights actually reduce the danger.
Start with the body.
Inside of feline inner ear sits a vestibular apparatus that functions as an onboard gyroscope, reading its orientation in space the instant a descent begins. There is no calculation required, just an immediate, automatic, physical response that appears in kittens as early as 3 to 4 weeks of age and reaches full precision by 6 to 9 weeks. Signals reach the brain, and the body immediately acts. None of this matters unless the skeleton can execute the maneuver, which is where cats become genuinely unusual. Lacking a functional clavicle gives their shoulders a range of motion no human can replicate, and their backbone bends with enough flexibility to twist the front and rear halves almost independently. That combination of internal gyroscope and skeletal freedom makes everything that follows possible. Scientists were stumped by the physics for most of the 19th century because a spinning object in free fall cannot change its angular momentum without pushing off something external. When an airborne cat drops with no turning motion at the start, it should theoretically arrive at the ground in that exact same orientation, which meant landing on its feet was considered mathematically impossible. Yet, the phenomenon clearly occurred. French scientist Étienne Jules Marais ended the theoretical deadlock in 1894 when he captured 32 high-speed photographs of a descending feline at 12 frames per second. He presented the sequence to the Paris Academy of Sciences under the title Falling Cat. His images proved that cats generate all their midair spin from within their own body mass, with no external push required. Dutch physiologists G.G.J. Rademacher and J.W.G. Ter Braak built on that work in 1935, introducing a model that identified the bent waist as the key mechanical element. That framework became the foundation for the complete solution, which arrived when Stanford engineers Thomas Kane and M.P. Scher published their 1969 paper explaining the falling cat phenomenon. Kane and Scher confirmed the bend and twist strategy. The animal bends at its waist, dividing its body into two independently moving halves. Instantly, the front half tucks its legs inward and spins rapidly toward the ground, exactly like a figure skater pulling their arms in to accelerate. Meanwhile, the extended back half counterspins slowly in the opposite direction, keeping overall angular momentum at 0. The movement then reverses itself. Front legs extend, back legs tuck, and the rear half swings around to align with the front. Through 2 twists in opposite directions with a net 0 momentum change, the feline successfully faces the earth. Physicist James Clerk Maxwell had estimated the minimum height needed for this maneuver at roughly 30 centimeters, or about 12 inches, and in that small window of space, the entire sequence fires automatically. Altitude introduces an unusual variable, because greater height does not translate to greater danger. New York City veterinarians coined the term high-rise syndrome in the 1980s after noticing something that defied their own expectations in patient records. In 1987, a study published in the Journal of the American Veterinary Medical Association found that survival rates actually improve above 5 to 7 stories. Below that threshold, a descending pet is still accelerating, with muscles tensed and braced for a hard impact. Around that altitude, the feline reaches terminal velocity at roughly 60 miles per hour, compared to 130 miles per hour for a plummeting human. Once acceleration stops, the vestibular system stops sensing the downward motion, At that point, the animal relaxes completely. Its legs spread outward like a flying squirrel, expanding surface area, maximizing drag, and distributing impact evenly across every joint when the ground arrives. The data tracked 90% survival among cats dropping from high-rise buildings across New York City, including one that plunged 32 stories and survived. This is an adaptation refined over millions of years, producing survival numbers that no other animal can match.